Hello, we are Team YMK presenting our novel solution for privacy-enhanced RAG SENTRY. In a vanilla RAG setup, privacy risks show up immediately. Without tenant isolation, information from one organization can leak into another's responses. That's cross-tenant exposure. Even within a single tenant, highly sensitive content often slips into answers without proper filtering. On top of that, prompt injections can trick the system into bypassing safeguards, and embeddings themselves can even be engineered to smuggle hidden information. These gaps make today's RAG pipelines fragile and unsafe for production use, and this is exactly what our system is designed to address.
Here is the architecture of SENTRY. Queries originate from the client and enter the SENTRY gateway, which orchestrates the privacy and compliance checks. The prompt card identifies and blocks any malicious or unsafe query patterns. Authorization filters then validate the user's identity, role, and tenant access. Candidate chunks are evaluated by the safety re-ranker for sensitivity and policy adherence, while the context minimizer selects only the minimum set of safe chunks required for the response. Every decision is recorded in the audit log, ensuring a verifiable trail of allow and deny actions. Finally, the LLM generates responses exclusively from the filtered and authorized contexts. This layered approach provides robust privacy protections without impeding legitimate queries. Few of these features are under production.
Now moving on to the demo. The first page is the landing page, which provides two options, which is the login and the sign up. Every user has to log in before trying to upload a doc and perform RAG. On signing up, every user will receive an access token, which is a JWT token, which is used to make sure that the user is authenticated. After I log in, I get the token, then I can ingest a document. Then what happens is it chunks into FISs for fast retrieval. The chunking is done using the splitting on the text, and the embedding is done using the sentence transformers. We have used a matrix to scramble the embedding, and our proposed method of transferring the scrambled matrix for future use is using the Diffie-Hellman key exchange. After that, we can move on to the search page, where we can include a search query. Once we query the knowledge base, the solution checks for any kind of prompt injection, base text, and also blocks it. When the prompt is valid, we'll get an answer with a few metadata. And then finally, the system automatically writes an entry to the audit log so the admins can track every query.